So this might not be something new. So let's first talk about what a conditional statement is. Please write the following. Conditional statement is a logical statement that has a hypothesis and conclusion. You guys remember hearing the words hypothesis and conclusion before in science class? Hypothesis. So in science, what were some hypotheses that you would do? It's going to be blue. It's going to be blue?
Yeah.
And then what would be a conclusion?
It's not blue, it's actually red.
It's not blue, it's actually red? Like when you're mixing things? Okay. All right. Huh? An educated guess? Sure. That could be a hypothesis. All right, so here's an example of a conditional statement. It's written there below for you already. It says, if it is raining, then there are clouds in the sky. So a conditional statement is always written in if-then form, where the part that comes after the if is your hypothesis, and then the part that comes after the then is the conclusion. So if I hypothesize, if you get enough sleep tonight, then what would be an appropriate conclusion? Then you won't be tired. If I study for my test, then I'll get a good grade. If I get a home run in baseball, then I score a point, right? So, conditional statements written in if-then form. Hypothesis, conclusion. So, if I give you a statement that's not in if-then form, can you put it in if-then form?
Yeah.
So here's our statement. Two angles are supplementary if they form a linear pair. What do you think, Nate?
If two angles are supplementary,
Then they form a linear pair. That would work. Now let's quickly think. Think for a second because I'm going to flip it. Is that necessarily true? Are all supplementary angles a linear pair?
So do you not want me to write what I just
Yeah, don't write that.
Oh.
Not all supplementary angles are a linear pair, right? Because supplementary angles may not necessarily be adjacent to each other. So what I would start with is, again, if you said that, I would not mark that incorrect because you're writing it as a conditional statement. But what I would do is, I have a key word of linear pair here. Even notice it has the word if. So if I start with that and then end with that, it would make more sense. So if two angles are a linear pair, then they are supplementary. That's always going to be true. If I have angles that are a linear pair, they will always be supplementary. If I have angles that are supplementary, they may not always be a linear pair. Because you can just have two random angles that would add up to 180 degrees. Missing my they. Then they are supplementary. Okay? Now, please do use some wordsmithing to some of these conditional statements so that they do make sense grammatically. But I am not an English teacher, so I am not going to be grading you on how well written your sentences are. Okay, so conditional statements. So now what we're going to do is we're going to talk about how to find a counterexample of a conditional statement. You guys did a whole lot of counterexamples on your homework and yesterday in class. Now when we're talking about counterexamples in a conditional statement, what I need from you is an example that proves that the hypothesis is true but the conclusion is false. So an example that proves that the hypothesis is true, but the conclusion is false. So yesterday, I think our first one on that classwork assignment was if it's a piece of furniture with 4 legs, then it's a table. Do you guys remember that one? And then you guys would just say what? Huh?
No,
Some of you guys said a couch or a chair, right? So my hypothesis was if it's a piece of furniture with 4 legs, well, a chair has 4 legs, but it's false for the conclusion, which was then it is a table. All right, so let's look at this one. If the product of 2 numbers is even, so right there is your hypothesis. This part is my hypothesis. So the product of 2 numbers even. Then the 2 numbers must both be even. There's your conclusion. So I need to come up with 2 numbers that is true for the hypothesis, but is false for the conclusion. Meaning, I need something that is the product. Product is what operation? Multiplication. So I need the product of 2 numbers so that it is even. But I want the 2 numbers to not both be even. So if they're not both even, that means they're either both odd or one is odd and one is even. Give me 2 numbers that are odd.
Oh, would it be 2 and 5?
2 and 5. That would work because 2 times 5 is 10. So 2 times 5 gets us to 10. Is the product of my 2 numbers even in this example? Yes. But is my conclusion false? Are both my numbers both even? No. Here I have an even and an odd. So that would work. Why would an odd times an odd not work? Bless you. Can anybody give me an odd times an odd that results in an even? Yeah. Anytime you multiply an odd times an odd, it's always odd, right?
4 and 3.
4 and 3, so that's an even and an odd. That would work too. So pretty much any even and odd would work. Okay? Counter examples. So can you write a conditional statement, yes or no? Yes, I can. Can I come up with a counter example? Yes, hopefully. All right, so flip on to the back. Now we're going to start manipulating these conditional statements. Lucky for you, we're only going to do one type of manipulation. There's actually 4, and we're only going to focus on one, so that makes your life easy. And that one is the converse. So because we're making this section a lot shorter, you need to make sure you really master the converse, and it's as simple as this. A converse is when the hypothesis and conclusion are switched. So if you're asked to write a converse, you're physically going to just take your hypothesis and flip the spot with the conclusion so that it goes back and forth. Okay? You got it? Oh, gotcha. It is. Yeah, don't do that.
But I thought we did notes on that already.
You may have. You only had to go. That just brings in the normal CDF and the inverse norm. That's okay. Then you got it all done. All right, so write the converse of the conditional statement. So we have the conditional statement of if a person plays a guitar, then they are a musician. So what part's the hypothesis? Person playing a guitar, right? So that's your hypothesis. What's your conclusion? They are a musician. Is that true? Yeah, I would say if they're playing a guitar, you could call yourself a musician. You may not be a good musician, but you could consider yourself a musician. So when we do a converse, I'm going to move this part over here. I'm going to move this part over here. But we are going to do some wordsmithing to make it sound appropriate. So my converse could be, if a person is a musician, then what? Then they play the guitar. Good. Right. So is that true or false? That is false.
That changed.
Hmm?
So then they could play.
Well, so don't change the statement totally. So if that is false, let's continue down here. So go ahead and circle false. We need to come up with someone who is a musician but doesn't play the guitar. So someone who plays the trombone, or someone who plays the flute, or someone who plays the piano, or someone who plays the drums. Those would all be counterexamples. Your counterexample does not need to be written as a conditional statement. You can just say, someone who plays the drums, or whatever musical instrument you want to use, plays the drums. So you don't need to write it as, if a person is a musician, then they play the guitar, or play the drums.
Would that be for the counterexample?
Yep, that's for the counterexample. Or you could say someone who plays the triangle. Though that could be debatable. Do you think someone who plays the triangle is worthy of being called a musician?
Oh yeah, you could make some cool like noises with your pattern.
You could. That is very true. All right, so converse. Do you think we've got converse? So if I go back to, if you study for your test, then you will get a good grade, what would be the converse?
If we did a good grade,
If you got a good grade, then you studied for the test, right? If I say, if you're happy and you know it, then clap your hands, then the converse would be, if you clap your hands, then you are happy, right? Okay. All right. So now we're going to turn into the world of a biconditional statement. Oh, we already did this part. Fanciness. Okay, so write small because there's a lot that's going into this box. Okay, so we can write a biconditional statement when the conditional statement and its converse are both true. So a biconditional statement can be written when the conditional statement and its converse are both true. So in our last example, did we say that the original statement, if a person plays a guitar, then they're a musician, did we say that was true? Mm-hmm. Sure. We're being kind. Was the converse true? No. So that would not work as a biconditional statement. Okay, so we need to find something that is true both ways. When that happens, this is what you're going to do. So this is how you write a biconditional statement. So write this inside the box. You are going to delete the if and the then. Physically remove the words if and then from the conditional statement. Then once you delete those, and you're going to then place the words if and only if. Those are your key words for a biconditional statement. If and only if. You'll place if and only if between.
Can you use that big delete thing?
Huh?
You use that flag to delete?
Read it?
No, delete, write it down.
Yeah, I would. So delete the if and then in the conditional statement, and then place if and only if between the hypothesis and the conclusion. Keyword on the word between. Some students will put the if and only if in the front, and they're going to get it wrong. It needs to go in between the hypothesis and the conclusion. All right. Now there are not enough lines provided for you for the last example, so just make do with it. I apologize. I'll put more lines next time. So we're going to work through a series of conditional statements to show how you can get to a biconditional statement. So we want to end up with writing a biconditional statement about pentagons. So someone give me a conditional statement about pentagons. Here, I'll help. I'll do the hypothesis. If a polygon is a pentagon, then it has 5 sides. Perfect. All right, so our conditional statement is if a polygon has 5, or sorry, if a polygon is, not has, is a pentagon, comma, then it has 5 sides. Is that true or false? True. So if a polygon is a pentagon, then it has 5 sides. What would be the converse? Of that.
If it has 5 sides.
Good. So I'll wordsmith it. So I would say if a polygon has 5 sides, then it's a pentagon. Oops, that should have apostrophe. Is that true? Okay, so both the conditional statement, so that's true, and the converse are true. So since they're both true, now we can write a biconditional statement. Now this is what we're going to do. What did I say we do? We delete the words if and then from the original conditional statement. And what goes in between the hypothesis and the conclusion? If and only if. So my biconditional statement is going to be a polygon is a pentagon if and only if, oops, it's a pentagon. Or sorry, it has 5 sides. I didn't do that right. It has 5 sides. Okay? Any questions? Yes?